Okay, so this is something new that we introduced to year 9. So don't panic, you will see it again later. And the main reason we do this is because sometimes we see numbers like this when it comes to doing questions with Pythagoras and trigonometry, which is what we're looking at next. Okay, so a surd, these are called surds. In the US, you may have heard of them called radicals. Okay, so if you talk to any of your parents, they may recognize the word radical rather than surd. Okay, that's just two different ways of talking about the same thing. Basically, they're numbers that cannot be written as a fraction. So if you typed in √2 and pressed equals into your calculator, it would probably give you lots of decimal values. Okay, and same with √5, √13. Now √4 would not be classified as a surd itself because we know the square root of 4 is 2. Okay, so simplifying surds. So now we may be asked to simplify a surd. Okay, that doesn't mean get rid of it. It means that we need to make it look more simple. Okay, so this situation here, we've got 7 √2 plus 2 √2. Now, as I've said here, we can think of a surd as a term. Okay, so in this case, my √2 is my term. So it's just like algebra. If we had 7 √2 plus 2 √2, Maya Bean, what do you think we'd have? Oh, you're breaking up. I can't hear you. Perhaps I'll ask someone else. Okay, Amy, what would I have? Have I frozen or have you all frozen?
9 √2?
Yes, 9 √2. Awesome. Is that what you were, hopefully that's what you were thinking, Maya Bean. Okay, so we had 7 of them. We've got another 2 of them. We've now got 9 of them. Okay, pretty straightforward, hopefully. Now, we can't add this because these are not the same. Okay, so just like algebra, if this had said 3b plus 2c, we couldn't have joined it together. Okay, now this one here, again, like algebra, we've got 8 √7, take away √7. Now that doesn't mean the √7s disappear. Georgie, what do you think we would have if we had 8 √7, take away √7?
7 √7.
Lovely. Okay. Right, so we've got 5 √2 plus 4 √2. Jasmine, what would we have there?
9 √2.
Nice. Oops, that's rubbish writing. Abby, what would I have for this one, sweet? Abby, mic on?
I don't know.
You've got, okay, let's look at it, sweetheart. You've got 5 √11, take away 2 √11.
3 √11?
Yeah, exactly. Have a bit more confidence, darling. You've got the right answer. Give it a stab if not. Okay. Kelsey, what do you think we'd have here?
We would have 8 √5.
Nice. And Emily, what would I have for this one?
-1 √11.
Good. Now, as with any algebra, we tend to not, oh gosh, that's rubbish. We tend to not write ones, okay? So we would just have -√11, okay? So, hopefully that's pretty straightforward. Now, sometimes we might be asked to multiply them, okay? So adding and subtracting is just the same as like terms in algebra, okay? Multiplying, again, it's very similar to algebra in that we don't really worry too much about the root. We just multiply the numbers. So what I have here is I've got √5 multiplied by √7. I would have √35. Okay? Pretty straightforward. Now, this one's a little bit different in that sometimes we try and group things together. So if I've got the square root of 2 multiplied by the square root of 2, that means that we've got the square root of 2 squared, okay? Because there's 2 of them, yes? Root 2 multiplied by root 2 is root 2 squared. Now, what happens if we've got the square root sign and the square sign? We know that they are opposites, aren't they? Yes? So Indigo, what do you think is going to happen if we've got the square root sign and the squared sign?
Would you, sorry, do you do to the power of instead?
Well, it's already got to the power of 2, but because these are opposites, okay, they actually cancel each other out. Imani, is that what you were going to say?
Yeah.
Sorry, I picked you at the post, I just saw it. So we've got these two and they cancel each other out. So actually, that's just going to be 2, okay? But we can't forget our little root 3 here. So he's going to be there still. And let's just neaten this up because we said that the root 2 squared cancelled each other out. So we've got 2 root 3. Okay? Get rid of that. So root 2 multiplied by root 2, I've grouped those together. So I've got the square root of 2 times the square root of 2 just gives me 2. And then the root 3 is on his own. So Eliana, what do you think root 11 times root 11 is going to be?
Um, 11 times 11, which is...
Well, think about what we just said about the square root of 2 multiplied by the square root of 2 was just 2.
So would it just be 11?
Yeah.
And then...
Not even the square root, we can just say it's going to be 11 because these square root signs cancel each other out.
Simplify it, you just cancel it out.
That's right. So, I mean, secretly it would be this square root of 121, but we know that that is 11. So we're trying to make our lives as simple as possible so that if we have 2 square root signs over the same number, we can just get rid of the square root sign. Okay? Now, can I have a thumbs up if everyone's good with that? And hopefully, or maybe I should have is there a thumbs down? Oh, darn it, there's not. Is there anyone that's got no idea what I've just been talking about? Speak now, please. Abby, yes, Abby. Talk to me.
Oh no, I just generally have no idea. I'm so confused.
Well, darling, unfortunately, you say that all the time, and yet you always answer my questions properly. So I think you do have an idea. You're just not feeling as confident about it. So what part did you not understand here? Root 5 times root 7.
That one I understand. It's just the harder ones that have like the squared sign, which I don't understand.
What do you not understand about it? Squaring means multiplying by itself, doesn't it?
Yeah.
Yeah, so that means that's what we've got here. We've got the square root of 2 multiplied by the square root of 2. And so that means it's squared. And these two cancel each other out.
Okay.
Same thing here. You've got the square root of 11 multiplied by the square root of 11. So that means it's just 11. Okay, because the square root signs cancel each other out. Okay? Georgie, what's up?
Why did you write the square root of 121?
Because we could have done that, because 11 times 11 is 121. But then we know that the square root of that is actually 11. Okay? So if you had forgotten, you could have done that, and then you could have gone back to having 11. I'm fine with it, Eliana, but you just know your mic's on, okay? All right, so here we've got 3. Now the 3 has to be dealt with separately because he's not in a square root. So in the same way as we would have big numbers separately, we would have the 3 separate. And then we would deal with the root 2 times the root 5. So root 2 times root 5. Sarah, what would I have if I had root 2 times root 5? Mintaj, try and log off and come back in again.
Um, what do you do? What do you do? So 5 times 2 is 10.
Yep.
So what do you do? Square root of 10.
That's exactly what you would have. Yep. Okay. And then this one here. Sienna, what would I have here? Let's deal with the big numbers first.
Would it be 10 square root 15?
That's exactly what it would be. I did say that, Vintage. Did you not hear me? Oh, she can't hear me. Oh, what a numpty. Thanks, Imani. She tells me I can't hear her, and then I tell her what to do. That was a bit silly. Okay, so we've got a few more here. Hannah Stockley, can you help me out with this first one? So let's deal with the big numbers first.
Would it be 20?
Yep.
3?
Pardon?
Or no? No. Square root 9?
Well, so let's think about this. Because remember, we said that if this number was the same, we don't have to multiply the numbers together, do we? Because we know that root 3 multiplied by root 3 is just
3?
Yeah, so we would have 20 multiplied by 3. Okay, now this is a harder thing to make sure that you're on top of. And I can hear something keeps going in and out. Okay. Oh gosh, now I have to write something. I've lost my chat thing. Okay. Right, so here, yeah, so as I said, the big numbers we deal with first, and then the roots we've dealt with separately. So our final answer for this one would actually be 60. Okay? This one here, we have to remember that the square means that we are writing this thing twice. So we would have 3 root 5 multiplied by 3 root 5. Let's deal with our big numbers first. Our 3 multiplied by 3 is Hannah FL. Yeah, okay, perfect.
9.
Yep. And then the root 5 times the root 5.
5. Just
Nice.
5.
Awesome. And then 9 times 5 is 45. Okay. Now, here's one. The cubed means that we've got this thing 3 times. So we've got root 5 multiplied by root 5 multiplied by root 5. Now we have to remember that square rooting something means that if we're squaring square roots, we have to group them in pairs, okay? So I can only pair these two to get rid of my roots. So root 5 times root 5 would be 5, so that's where they've come from. And then this one is still there, okay? So we can't just say, oh, well, we've got 3 of them, let's all group them and get rid of the square root. We can't do that. We have to pair them up, okay? If we'd had root 5 to the power 4, then we could have had root 5 times root 5 times root 5 times root 5, and we could have had 2 sets. So we could have had this one would have been 5, and this one would have been another 5. So that would have been 25. Yes, Amani.
So when you're adding, you just put root 5 or whatever the root is, and when you're multiplying, you have to work out the multiplication.
Yes, you've actually got, yeah, it's the same with algebra. Like, we would have to do some multiplying. So if there's big numbers, you would multiply them. And if there's roots that can disappear, then those roots should disappear. Okay? Maya?
So basically, you cancel out 2 of them to make the 5, right?
Yes, because we know the square root times the square root gets rid of the square root sign. But it has to be, this has to be the same number. So up here, when we had root 2 and root 5, we kept root 10, okay? And so that doesn't, we can't just say there's 2 roots so it disappears. It only disappears when the number is the same. So this root 3 and root 3 just became 3, okay?
Okay.
Indigo?
Is like the last part you did, like
This one?
where it compares, is that something that makes sense, or is it one of those things you just have to know and remember?
Well, see, I mean, you could have, oh gosh, root 5 squared multiplied by root 7 squared. And so that would end up being 5 times 7. Because these cancel each other and these cancel each other. So you just have to look to see which ones group together. Okay, my main thing for doing this cubed one was to make sure that you're aware that if you can only pair them up, you can't just get rid of the square root totally.
And also when you're adding, it's like you just have to cancel each other out, but then when you're, I don't understand the whole thing where you said timesing, it's different, like you have to pair them.
Well, so adding, you just group them if they have the same root, like I'm showing you here. So these were both root 2, so we could add them together. There's just 9 of them. They're like algebraic terms.
But what if they're like different numbers?
Pardon?
What if they're different numbers?
Then you couldn't. So that's why we said this one, you couldn't add them together. So that would just be as it is. You couldn't do anything with this because this is a root 5 and this is a root 7.
Okay.
Yeah?
Yeah.
Okay. Okay, we feeling okay about this? Okay. I'm very, oh yeah, good, am I? I'm very aware that I was late. Oh my gosh, that's so annoying. But I want to practice some questions. So, which questions did I give you? Okay. All right, I haven't talked about dividing. But what do you think would happen? Oh gosh, can you still see all this? Hopefully you can. If I had root 7, oh no, let's say 3 root 7 over 2 root 7. Is there anyone that think that they could take a stab at that as to what would happen? What's the normal rule when we have the same thing happen? Pardon, Amani?
Would they cancel out?
Yeah, what would cancel out?
The 7.
The root 7s, yeah. Because they're the same thing. And the rule is, if you have the same thing on the top and the bottom of a fraction, it means you can cross it out. Okay? So my answer here would just be 3 over 2. Georgie? Georgie?
I have a question about adding them.
Yeah.
So if it's like 2 root 5 plus 4 root 5, would it be 6, but then times plus 5?
No, just 6 root 5.
But doesn't the root 5 cancel out?
No, that's only when we're multiplying, Angel.
Oh, okay.
Yeah?
Okay.
It's like having 5b multiplied by 2g. No, yeah, 2g. We would have 10bg. Like it's not, they just go next to each other. And so that's why we did this bit here. But if we had the 5c multiplied by 4c, we would have 20c squared. So that's why it's a little bit different when they're the same thing. Okay? So for the last 10 minutes of this lesson, can you please have a go? Can you see this one? Do you know which one I'm pointing at now? I don't know what you can see and what you can't see.
The thing hasn't changed.
Oh, okay. Can you scroll down, please? Okay, so can you have it? So in the Google Classroom, there's a Longman text. Okay, if you can just have a go at, or let me just check this one. Okay, yeah. So can you try the Longman text, exercise 69? Okay, so for the last 10 minutes, you're going to have a look at the Longman exercise 69. So it's just the first one. There's a few questions. The answers are on there, so you can check to see if you've understood it. Okay? I'll stay on here. So perhaps if you all stay on here and you can have a go at those questions and you can ask me if you're stuck with them. Okay? So on the Google Classroom, find the Longman exercise, and it's exercise 69. Okay? I'm going to stop recording now though.